Okay, now that we were done with this main smoke, let's make some ground smoke. So I'm gonna make another geometry node and then make it red, and this time I'm gonna call it, sorry, fx wave. Yeah, this ground smoke looks like a wave from the center, so I'm gonna call it wave smoke. So before do that, let's make let's quickly make a light, because now we see there's our main smoke, but we don't see any like a volume, like a highlights or shadow part. So if we just to quickly make this skylight up here, just click skylight and it'll make these two different lights, sunlight and skylight. And let's move down here. Now you see here, those lights are taking account into our viewport, but this time I'm gonna turn off this skylight because I don't like the bright background, but still like a sunlight is still affecting to our viewport, so this is good enough. And let's dive inside this FX wave. Now we're gonna make a ground smoke. So ground smoke is just because of the nature of the ground smoke, I wanted to start with the circle and change the primitive type to poly again, and then this time orientation will be the flat to the ground surface, and let's make the division high enough so we get a nice circular shape. Okay, that'll be all here. And next will be, because we don't have any normal, I mean we have normal direction, but it's pointing wrong direction. So we want to make the normal direction outwards. So we have to change a little bit. So let's make a pointer angle and name it just to n. And I'm gonna make this n equal at p. So now we see a little different visualization, but please ignore it because it's n. So if we check this box, we see the normal direction pointing outwards. So this is what we want. So same thing happening as this main smoke. I'm not gonna explain this that much, but we do need initial velocity. So initial vol. Let me check what I did. You might be curious about how it works, this part, why this works. So let me explain a little bit. So we just assigned p to n. So that means let's get back to the 2D space again. So if we have this point here, right? We have point, and here x and y, and this point's position is defined by each value of x and y. So this is going to be, for example, like 1, and this is going to be like 2. So 1 comma 2. So this can be described as this point position, right? Like position. On the other hand, the position itself can be a vector as well, because this 1 and 2 can be starts from 0 and pointing this this words pointing this way, right? So this is going to be our magnitude, our length of the vector, and this is going to be our arrow. So this again, this position vector can be also a vector pointing to somewhere like this. So that's why, if you imagine we're seeing the circle from the top view, so this time it's going to be like X and Z. So we have a circle, and this circle has the points, and points has the position, right? Its position. So like I explained above, so this position can be also a vector like this, and we're assigning this to our n. That's why each point gets this type of n direction, n vectors, and we're going to use that as our velocity eventually. But and then same thing, you know, multiply some noise. So this time the noise we're using is not anti-aliased but turbulent noise. So turbulent noise has a lot of noise type, but we're gonna just stick with this alligator noise for now, and just connect to P2 position, and then we're gonna multiply like before. So first input will be n. Right now we're seeing the direction of the n, and then multiply this noise, and then feed into our velocity. But for visualizing purpose, I want to make it n for now. So now we see some variation in terms of the length of the normal. Now we can use this as velocity, but before that I want to make some changes. First of all, I want to make this frequency like before 222, and I want to, before multiply here, I want to create a fit. Now this fit is same as we've used before, the fit expression, same thing. The VOP is just like a visualizing those code. So I'm gonna connect this to the VOP, and then these source and minimum and destination minimum max, and it's the same thing, right? And I'm gonna put here minimum just same 0, 1, and I want to make the destination minimum to 0.2 to 0.8. So that's so this minimum maximum, the source minimum maximum, it's up to this previous node, because the alligator noise, the result of this noise is from 0 to 1. That's why we can just leave it like that, 0 to 1 source. But then we want to remapping those range to something like this. So quickly draw here. So originally the noise was alligator noise. Alligator noise was looking like this. So the minimum was this minimum value in y, in y direction. The minimum was 0, and the maximum about here, right? The maximum will be 1. So it's gonna always result in a number range from 0 to 1, and we're remapping using fit VOP. So this graph will be changed. So for example, this is 0.2 and 0.8. So we're gonna squeeze it down. We're gonna make it squeeze down a little bit, so it's gonna much less here and much higher in terms of minimum, something like that. So it's not a big deal, like it doesn't do anything much here, but I just want to make the range a little tighter. And then because this amplitude, we're not changing this amplitude here, so I want to just multiply constant this result by 5 and then feed into the input 2. So because we're changing this range, so there's not much variation, but we still see the variation, right? Like this part is really long, but this part is short. But without this fit, the contrast is too much. So that's why I just wanted to make it less contrast. Okay, and then finally, let's make some value into the input 3. Middle click, promote parameter, and then click here and name it V scale. And just make it default 1, and then go let me check if I did same thing. Okay, same. Okay, now let's go up, and now we have a V scale parameter, and we can just set it to 100 here. Then we're gonna get giant exploding initial velocity vectors like this, right? And then what we're gonna do is the same thing as before. So create a pop network. This is gonna be our wave source sim. So it's gonna be particle sim again. Okay, so let's dive inside. Turn off this. Okay, before we do that, I forgot to change this N to V, right? It's the pop network won't understand this what N is, so we have to make sure we connect to the V. And so let's go inside here, and we already see something change it. And like before, it's gonna pour out the particles forever. So we need to make changes onto the go to birth tab. Same thing, constant activation when the frame number is less than 10, and then the birth rate will be 300,000 per second. And then attribute, nothing changed. Okay, so let's play it again. So it's gonna make this a big wave motion. It's very cool, right? But this time in the first frame, frame 1, I wanted to, I don't like this this wavy shape already appeared on the first frame. So let's change this birth type to this jitter birth time to negative. So it's gonna the initial position of each particle will be negatively. That means like inside the sphere, it's gonna randomly positioned inside those circle, and then just if we hit play, it's gonna make just a noisy pattern again. So it's very cool. Okay, next. Again, this reaches too far away. So we're gonna need a pop drag node, and same thing. We're gonna reduce this air resistance much lower, so it's not gonna stopping that much. Yeah, this is nice. This is very cool. Okay. Now same thing. Go to pop object and go to here, object name, and right click, copy parameter, go upward, and here we paste those reference. So we get the result, we're pulling the result of the particle sim. Okay, cool. Now it's easy, right? Because now we're already done with the first smoke. So go to the first smoke, this main smoke, and we're gonna just copy some nodes from here. Some, we're gonna do repetitively. So what we're gonna copy is just this part, and then go copy like a Control C, and then go to wave again, and then paste again. Okay, now I'm pointing to the same cache file, so it's showing us the main smoke, but we're gonna change it later. Alright, so in the result of this wave source sim, we connect to set attribute again. So now you see the alpha is working. It's disappearing, right? Because we're feeding the age attribute again here, and we're feeding into alpha attribute and then p scale, and also multiply with our previous velocity here. So now the velocity also gets shorter, right, by the time. So it's cool. Okay, same thing. Okay, I'm gonna add some attribute here again, point attribute, and I'm gonna call this to random y. Okay, so random y, what it means is, because we started with the flat circle, and the pointing, the normal direction is absolutely like y direction 0. So that's why if we see from the side view, it never goes to up and down. It's always, sitting on the ground plane, which is, always like, if you see here, the center of the particle will be always a 0, right? The height. So it's really, completely flat. But later on, we're gonna convert these points to volume and then do the volume simulation here. Before do that, let's change this name to not explosion sim, this time wave sim. So because of that, if it's too flat, it's not gonna make a very interesting motion in the DOP network here. So I wanted to make it a little like little thickness. So right now, if this was ground, so ground y is 0 right now. So every point is sitting here, right? But I want to make the particle randomly go up to 0.1 meter. So this particle go to here, this particle to here. So I wanted to make sure all the particles sitting in between 0 to 0.1 meter. So randomly, So we have some like a nice thickness to do in order to do our simulation. So to do that, like in attribute wrangle, really simple syntax. I want to make a variable called r, and it's gonna be rand function with id attribute, and and semicolon, and I want to feed it to our py like this. You see a little bit changed here. Now particle, like if you see the difference, now particle moved, like in y direction. So this rand expression result in the random attribute, random value between 0 to 1. and we're feeding that into p dot y. That's why those particles are sitting in between 0 to 1. But I said it's the 1 meter is too high, so I wanted to make it a little lower, but still like or randomly at the same time. So I just simply multiplied by 0.1. So it's gonna be now it's gonna be randomly 0 to 0.1. Okay. So now we have some thickness. So that's all. That's all we need. And now we need to make it convert it to our volume. Same thing as before. Now let's just see the density parts from here. I'm gonna make this point radius scale like 0.2 this time, so much smaller. And then everything else is same. We added V here, so as a result we have 2 volumes like before. Okay, now all we can do is just do another smoke simulation, but this time I'm gonna just delete this node and just dub network, make another new dub network and call this as a wave sim, because this is easier to change, easier than, you know, adjusting the previous setup. So inside here, just want to make some basic setup again: power solver and smoke object and resize dynamic fluid, and finally volume source, and connect it to the responding input. And we're gonna also need ground plane as well, and merge, connect like this, and then hide our ground plane. So first of all, we need to change this volume source again. Let me check. Okay, same thing happening. So input will be the first, and then initialize, change to something else, and then come back to smoke, and it'll make 3 fields for us. So this time also we need to change this source volume as density, and it's gonna go to target field as temperature. Also this velocity, I always told you, change it, it needs to be a lot lower, so 0.1. And also we need to turn this max bounds off so that it can contain the smoke enough. And also this padding, we need to make it larger. And also we need to change this name to wave. And then in the wave, let's increase so we can see the result fast first. Okay, in the smoke object, let's increase this initial bounding box. So 10 in x-axis and 10 in z-axis. So it contains this. This is really fast movement, so we have to make sure in the first frame we have to have enough bounding box, and then later that. Okay, here has some error. I think that's because we have to relink. So division size we need to copy and go upward, and here has the error because this was connected to the previous dub network we deleted. So we need to reconnect by pasting. So now it's 0.4. Okay, so let's go back and play it. And now we see some square shape. It's a little bit weird. Okay, it's getting better. Okay, so here I'm gonna make our quick view, which is Control 7, and then we can always come back by pressing 7. So before, let's delete this flipbook, and let's make another flipbook. Okay, leave like that, just start. Okay, it's doing something cool. But in the beginning, we see some like a jiggling part around the edge. That's because there's lots of points, but then the smoke doesn't follow that much. Okay, first of all, we need to, in the ground plane, I lowered a little bit in terms of Y. Here, just put minus 0.1 because the voxel might be deleted by below the surface, below the ground plane. So I just made it a little lower, so there are more voxels take account in the simulation. Okay, so then we need some substeps. Here on the DOM network, we have substeps here. Because substep is because the particle from the top view, our particle source is traveling really fast, right? And each particle becomes a volume in order to source the smoke. So in the first frame, this source made a smoke, made a volume around here, right? But then in the next frame, frame 2, that source moves here. So there's some space in between, and there's no volume filled in. So that's why we see like this steppy volume movement. So if I show you again, like here, you see here like some dots. In order to get rid of that, we need increase this substep. That substep meaning you just make some more particles in between frame. Okay, let me check one more thing. In the frame like 10, for example, I want to check what the smoke looks like on frame 10. As you can see, it's not the same. You know, the particle seam is already reaching out here, but then the smoke is really smaller than that. The bounding box is not catching enough. So rather than increasing this padding more, we can also use this tracking object tab. This tracking object tab is, if we can just add null here and then name it to just to track, and then we can use it directly here. So check on this track by object, and in the subpath we just put our track node here. Now if we play, it's gonna make much smoother simulation, right? It's tracking really well. So if we go up and down, back and forth, the source is almost the same range. So we get almost like everything is covered enough. Okay, that's very cool. Okay, let's okay, let me just go to creation, and I check this. I check the solve on creation frame on, so it calculates from the first frame. And then copy this object name, and copy, and go upward, and here we paste, and the data will be density, so we can see the shadow, nice shadow, and something like that. Okay, let's cache it again. I mean, this is not really caching to our hard drive, it's just flipbook. So this is very cool, right? Now it's done. Okay, press this button and then open the sequence list again so we can do some comparison. So back to the previous what I explained. Oops, what is this? Okay. So here, in order to use this substeps, we're gonna just increase just a double, not that much, because if you increase this substep, it's gonna take a lot of time. Like now, it's gonna take a double time. So be careful, like don't increase too much. But in order to the substep works, we need to attach the retime node, retime sub, before converting to the volume here. So after particle sim, we need to retime, and then change this substep to 2. Then it's gonna make more. Now let's see the result. Let's compare. So reset simulation, go to 7, and I'm gonna flipbook. Now we get second flipbook, and now we can compare. Oh, oops, I did wrong camera before. So let's finish this first, and then let's go back to the previous setup, which was not substep. So substep, as we increase the substep, it takes double time, but it gets nicer movement. Okay, it might not be that dramatic changes, because we set the division size higher. So if we lower the division size, we're gonna see the more details. Then we can see more dramatic changes. Okay, it's done. So in the same viewport, I want to just make the substep 1 again and reset, and then disconnect this one more time, and then do it again. Okay, now it's fast. So let's compare. It's a very different, right? Especially, okay, in the beginning of this simulation, without the substep, it's making a little odd movement. It's the smoke not following that well, but in the second simulation, like if we increase the substep, it's following pretty correctly. Okay, let's just leave it the substep 1 for now for faster simulation. Now let's make some changes in the DOP network. We'll go dive inside, and in the pyrosolver, we're gonna change something. So first of all, we need to turn off this again, enable combustion. We're gonna turn off, And in the shape tab, we're not gonna make any other microsolver anymore in here. We're gonna use disturbance and turbulence. And I'm gonna use dissipation a lot lower, so we can keep the smoke a lot longer. And then we're gonna increase disturbance a lot, like 10 times more, and then turbulence as well, like 10 times more, something like that. And then in the turbulence tab, we're not gonna change that much. By default, it's using the density as control field, so let's leave it. And in the disturbance tab, we're gonna use the control field again, density. So where it's heavier density, it gets more disturbance, like so. And then okay, and then anything else? Okay, everything looks same. And let's see some changes. Okay, reset simulation and disconnect, and make sure we have same viewport, and then flip. Now we already see the difference, right? We have some disturbance and the turbulence, and it makes us some nice details in the center as well. And it also, with the lower dissipation, we also get the we also make the smoke last longer, right, in terms of density. Okay, this is nice. Like this, really explosive. Let me make the last change here in the simulation. What I want to do is when I try the simulation, so this is the ground, for example, and we have main smoke around here, right? Main smoke, and then we have a ground smoke, like a wave smoke here, right? So when I tried this first, it looks really nice, but at the same time it's making really high ground smoke, like a wave smoke. It was too high. It's up to here. So what it makes is it makes the main smoke looks smaller. You know, that's kind of a problem. You have to think about it really carefully. So we have to make some changes in order to make our main smoke looks what is that called? In order to make our smoke really pronounced, you know, otherwise it's gonna get feel like not as big. So I wanted to make this kind of like a length of the smoke, keep it same, but I wanted to decrease those heights a little lower, so it's gonna make more like a lower but large area at the same time. So anyway, we need to push this volume like downwards. So in order to do that, I did a really simple thing. If you go to the power solver in the first tab, simulation tab, you'll see a lot of different parameters, but I wanted to change this buoyancy lift, buoyancy and direction. Because of the if we have a temperature, because we have temperature here, right? Because we fit in density to temperature. So if we have temperature in the dynamics, the smoke basically, by the default nature, it goes upwards. That's why whenever we do the quick smoke test, it always goes upward. That's because of this buoyancy lift and the direction. And the direction is pointing to the upwards in y direction, and the lift, the value is 5, so it's going up. So I wanted to make this value really high. But if we make it, if we leave like this, it's gonna go up more, right? So I'm gonna change this direction to negative so that it's gonna push smoke to the ground more. So let's see what has been changed. So reset and go to here, disconnect, and do it again. Okay, let's compare. Here in new one and before new one, you see the overall height is getting shorter. So this doesn't seem very important, but a lot of time you have to deal with this type of thing. Like you have to make this, another element smaller in order to make the other object much bigger. So that's very important. So now it's a much lower, but at the same time it's same size, same length. It's pretty cool, right? Okay, I mean it's already cool even with this higher value, higher division size. So if we, as I did, if we reduce this division size and do the substep double, it's gonna make a much nicer result. Okay, and that's it. So wave sim is done. So let's cache it out. And here we have to change it here because it was no, we don't have to change. Okay, let's check if this is pointing same thing. Okay, it's different. So let's go and on the wave, copy this object name and reassign to here. Now it's changing. So now we have okay, nice result coming out of this dot network. And then same thing here, leave the density voxel as it is, but change the velocity voxel size double. And let's change this name like cache wave sim, so it's gonna, if you create a file cache, it's gonna affect your file name because it has $OS. So I'm gonna swap this with what I'm done before. So let me just copy this cache. Okay, and you need to make sure you have to load from this button on. Okay, if I play this, it looks like this. It's a shame because we're only showing from the side view, right? I mean, because that was my initial idea, so I have to do this. But it's up to you guys. Like if you want to, change your camera, I want to, show all these two cool parts. You have to change the camera, but you also have to have different background image, that fits to this 3D camera view. Okay. All right. So in the next chapter, we're gonna quickly make another smoke, which is trail smoke. Okay. See you there.